Now we are going to see the quality plan that is applicable for a toughened glass, and the standard what we follow is EN12150. If you see the glass coming to toughened glass, it is coming from cutting, grinding, washing. So what are all the standards applicable in cutting, grinding, washing that will be measured in the tempering as well? And the main functioning in tempering, that is the test parameters what we look at tempering is overall bow, roller wave, edge lift, fragmentation test, and the strength that we are going to focus in this particular tempering department. Now let us understand one by one each test parameter. Let us take overall bow. The tool what we use to measure the overall bow is a straight ruler or a stretched wire, and through the help of taper gauge we are going to measure the overall bow. And how we are going to measure? We need to see whether it is a clear uncoated float glass and whether it is an enameled glass. In order to measure the overall bow, the allowable tolerance what is given to us is 3 mm per meter. So if my glass length is the 1000 mm, the allowable bend in that glass is 3 mm. And if my glass is an enamel glass, the overall bow is allowed is 4 mm per meter. Now let us take and the frequency of testing. The frequency of testing will be for every 2 hours or whenever there is a changeover. Now let us take the next parameter, that is the roller wave. The standard what we follow is EN12150. The tool what we use to measure the roller wave is a roller wave gauge or a straight edge and a feeler gauge. Here also, if it is a clear float glass, then we need to, the overall roller wave is allowed is 0.3 mm, and for the enamel glass, the roller wave allowed is 0.5 mm. Now let us take the next test parameter, that is the edge lift. The standard what we follow is EN12150. The tool what we use to measure the edge lift is a straight edge and a feeler gauge. For this, we need to see it is the edge lift is always dependent on the thickness of the glass. If my glass thickness is 3 mm, the maximum value allowed is 0.5 mm. If my thickness is between 4 to 5 mm, the maximum edge lift value is allowed is 0.4 mm. If my thickness is between 6 to 12 mm, the maximum edge lift value allowed is 0.3 mm. And for enamel glass, the edge lift allowed is 0.5 mm. And the frequency of edge lift measurement shall be for every 2 hours or whenever there is a changeover. Next, let us take the fragmentation test. Generally, by looking at the glass, if you see in a toughened glass or a heat strengthened glass or an annealed glass, by looking at the glass, one may not be able to distinguish which one is what type of a glass, whether it is an annealed or a HS or a toughened glass. That can be said through the help of fragmentation test or through the help of non-destructive method, that is with the help of stress levels. Let us take the destructive method of test, that is the fragmentation test. The standard what we follow is EN12150, and the tools what we require is a hammer, pointing steel tool or a hammer which is weighing 75 grams or a spring loaded center punch or a similar applicants that can be hardened, which is having hardened point. And we need to see the type of glass. It is a float glass, and we need to see the thickness, whether it is a 3 mm or 4 mm or 12 mm or 15 to 25 mm. The minimum particle count, based on the particle count we will say whether it is a heat strengthened glass or a toughened glass. For a 3 mm thickness glass, the minimum particle count should be 30. For 4 to 12 mm, the minimum particle count shall be 40. And for 15 to 25 mm, the minimum particle count shall be 30. And the frequency of testing will be for every 2 hours or whenever there is a changeover. Next, let us take non-destructive method of test, that is through stress levels, measure of stress levels. The standard what we follow is EN12150. This we are going to measure through the one equipment known as GASP. And we need to see whether it is a clear glass or tinted glass or a coated glass. And for a toughened glass, the stress value should be more than 69 MPa or Newton per square millimeter. And the frequency of testing will be every 2 hours or whenever there is a changeover. Now we are going to see the quality plan for heat strengthened glass, and the standard that is applicable is EN1863. The parameters what we need to check in heat strengthening process is the thickness of the glass that we have already done in cutting, grinding, the width and the length of the glass, that is already we have done in cutting and grinding, diagonal measurement, hole diameter if at all the glass is fabricated. And the actual parameters what we need to check in heat strengthening process are overall bow, roller wave, edge lift, fragmentation and mechanical strength. Now we'll understand one by one the tempering heat strengthening parameters. Overall bow, the standard that is applicable is EN 1863. The tool what we use is a straight ruler or a stretched wire, and we use taper gauge to measure the deformation. Now we need to see what is the overall bow tolerance. If it is for a float glass, in a meter the overall bow allowed is 3 mm, and for enamel glass the overall bow allowed is 4 mm per meter. And the roller wave, that is measured through roller wave gauge or a straight edge with the help of taper gauge. Maximum roller wave for distortion is measured is 0.3 mm, and for enamel glass it is 0.5 mm. Now let us take the edge lift. The standard what we follow is EN 1863. The tool what we use is a straight edge with the help of feeler gauge. In order to, the edge lift will be dependent on the thickness of the glass. So for a 3 mm thick, the maximum edge lift allowed is 0.5 mm. For 4 to 5 mm thick, the edge lift allowed is 0.4 mm. And for a 6 to 12 mm thicker glass, the maximum edge lift allowed is 0.3 mm. And for the enamel glass, the maximum edge lift allowed is 0.5 mm. Now let us see the fragmentation test values for the heat strengthened glass. The standard what we follow is EN 1863. The tools what we use is a pointing steel tool, hammer weighing 75 grams, spring loaded center punch or a similar applicants with a hard end point. Here we need to understand, whenever we break any heat strengthened glass, we need to understand 3 parameters, that is, at least one edge of the fragment shall reach the excluded area. The number of island fragments shall be counted and not more than 2, and each island shall be weighed. And the third parameter is what we need to understand is the particles shall be collected and weighed. So in order to understand the breakage pattern for a heat strengthened glass, we need to consider 3 things. First one is, whenever you break the glass, one of the crack should end at the other side of the edge, and we need to see the number of islands and the particles. We need to weigh the islands and we need to weigh the particles to conclude whether it is a heat strengthening or not. And the frequency of testing shall be for every 2 hours or whenever there is a changeover. Now this is a destructive method of testing what we have seen so far. Now let us take a non-destructive method of testing of heat strengthening, that is the mechanical strength, that we are going to check through EN 1863, and the tool what we use is a gasp. In order to measure the gasp, the stress levels what we require for a heat strengthening glass is 24 to 52 MPa or Newton per square millimeter. See, and the frequency of testing shall be once in 2 hours or whenever there is a changeover. Now we will be understanding the quality plan for a toughened glass, and the standard what we follow is EN 12150. Similar to heat strengthening glass, the parameters remains the same, that is the overall bow, roller wave, edge lift, the fragmentation test and the mechanical strength. Now let us describe everything in detail. Overall bow, the standard what we follow is EN 12150. The tools what we use are straight ruler or a stretched wire with a taper gauge. The overall bow allowed per meter is 3 mm, and for enamel glass the overall bow allowed is 4 mm per meter. In a similar way, the roller wave, the gauge what we use is a roller wave gauge or a straight edge with a filler gauge. The maximum allowable roller wave value is 0.3 mm and for enamel glass it is 0.5 mm, and the frequency of testing shall be once in 2 hours or whenever there is a changeover. Now let us take edge lift. The standard what we follow is EN 12150, and the tools what we use are straight edge and a filler gauge, and the edge lift is dependent on the thickness of the glass. So for a 3 mm glass, the edge lift maximum value is 0.5 mm. For 4 to 5 mm, the edge lift maximum values are 0.4 mm. and for 6 to 12 mm thickness, the maximum values are 0.3 mm, and for enamel glass, the maximum edge lift allowed is 0.5 mm, and the frequency of testing will be for every 2 hours or whenever there is a changeover. Now let us understand the fragmentation concepts of the toughened glass. The standard what we follow is EN 12150. In order to do destructive method of testing, that is the fragmentation, the tools what we use are pointing steel tool, hammer weighing 75 grams or a spring-loaded center punch, similar appliance with a hardened point. And here the fragmentation count is dependent on the thickness of the glass. For a 3 mm thickness, the minimum particle count shall be 30 numbers. For 4 to 12, the minimum particle shall be 40 numbers, and for 15 to 25, the minimum particle count shall be 30 numbers, and the frequency of testing shall be for 2 hours or whenever there is a changeover. So far we have seen a destructive method of testing, that is the fragmentation. Now let us see the non-destructive method of testing, that is the mechanical strength through with the help of gasp. The minimum values for mechanical strength for a toughened glass is more than 69 Newton per square millimeter or MPa, and the frequency of testing shall be for every 2 hours or whenever there is a changeover. Now we will understand the defects that are